Section 2, Video 2. This is an exercise that allows us to look at pairs of angles to decide if lines are parallel. So we have to look at this with the proper lens. We have two scenarios. We have K and W, which are the lines in question, and we're going to look at the transversals T to see if they're parallel, or the transversal X. But you also have the scenario where the two lines you're looking at being parallel are X and T, and are using the information of K being the transversal or W being the transversal. So we're going to first of all use our vocabulary and label them, decide what lines we're talking about as being possibly parallel, and then coming to a conclusion. So 16 and 1. 16 and 1 are dealing with K as the transversal because it connects those two angles or those two intersection points. So X and T are the ones we're trying to decide if they're parallel. 16 and 1 are corresponding angles. In order for the lines to be parallel, they must be equal, and that's what they tell us. So we can conclude that X is parallel to T. And that is the exercise. So we're going to focus. There's a lot of information here, so we need to really focus on what information they're giving us. So 14 and 9. So 14 and 9 are connected by the line X, so that's the transversal. By the looks of it, again, they are corresponding angles, and they must be equal in order for us to conclude parallel, and they say that. So since X is the transversal, K and W are the lines it intersects, and those are the parallel lines. K parallel W. One and 8. Now they are connected by the transversal T. They look like they are outside the parallel line, so exterior, and same side of the transversal. So these are same side exterior angles. But we said that if that's the case, then they must be supplemental in order for lines to be parallel. And they tell us that they are equal. So that will not work. All right, next one is 4 and 10. Now this one is a pair of angles that are not connected by a transversal. There's nothing directly connecting the two of them. So because of that, this is a no. We do not have any information from those two at this point. We cannot do anything. It must be connected by a transversal. Number 5 is 3 and 5. So they're connected by the transversal T. They look like they are alternating sides of the transversal and both interior. And for lines to be parallel, they must be equal. That is what they tell us. So since T is a transversal, K and W are the lines parallel. Twelve and 6. 12 and 6 are dealing with W as a transversal. They are alternating angles on the transversal. They are exterior angles, and they must be equal for the lines to be parallel, and they are. So we can conclude X parallel to T, since W is the transversal. Number 7. 14 and 10. They are both same side of the transversal, because we're looking at X as being the transversal. They connect the two angles. Same side interior, and again they must be supplemental for the lines to be parallel, and they are. So we can say K parallel to W. And our last one, 5 and 6. Well, 5 and 6 look like they are a linear pair. But in order to show two lines are parallel, you must have angles from two different intersection points. And these are at the same intersection point. So you're not involving any other grouping of points at an intersection or grouping of angles at another intersection point. So since it's isolated, we cannot do anything with it. And this ends section 2, video 2.